Alright, final question of the quiz. Question 3. A 20 kilogram object is moving with an initial velocity of 5 meter per second, acted on by a force of 2 Newton. So this graph here is showing us the motion. So we have to determine the velocity of the object at 10 meter displacement. Okay, and then question B. A car with mass 1500 kg is moving with constant force acting on it along its direction of motion. Upon achieving a speed of 20 meter per second, it delivers a maximum power of 100 kilowatt. Later, the car enters a 50 meter rough road and decelerates to a speed of 10 meter per second. We have to determine the constant force as well as work done to overcome the frictional force on the rough road. Okay. Alright, okay, so let's try and solve this question. So this is the graph just now. So the information we have is the initial velocity, which is equal to 3 meter per second. 5 meter per second. 5 meter per second. And then we have the mass, which is equal to 20 kilogram. Okay, so work done is the area under the graph. Okay, so for this one, we have to find the work done untuk. Kenapa mau cari work done is because we have to find the value of delta K. Okay, why do we need to find delta K? Is because we are looking for the velocity of the object. Okay, so velocity of the object at 10 meter displacement, meaning we have to find the work done from 0 to 10 meter lah. Okay, untuk the graph ni. So this is a trapezium, so we can solve this by using trapezium punya formula lah. Okay, so the work done is equal to 15 joule. Okay, so now we can use work equal to delta K, where work is 15, so this is half mv square minus half mu square. Okay, so this is 15 equal to half m equal to 20 kan saya bagi. Okay, 20 plus 2v square minus half 20, u is 5 square. So you should get the velocity to be equal to 5.15 as the velocity of the, what was it again, the object lah. So okay, so that is your solution for question A. Question B pula, we have the mass, which is 1500 kilogram, and then we have the velocity 20 meter per second. 20 meter per second, and then maximum power, which is equal to 100 kilowatt. The displacement 50 meter, and then the velocity 10 meter per second. Okay, so for this question we can actually use the formula P equal to FV. Okay, so this is only used when the force is constant. Okay, when the force is constant and the velocity is constant. Okay, constant speed lah, right? So F is P over U, which is the P yang maximum power tu lah. Okay, which is 100 kilowatt divided by the initial velocity, which is 20. Then you should get the constant force punya value to be equal to 5,000 Newton. Okay. Lepas tu, the second question, dia minta apa? Work done to overcome the frictional force. So the work done to overcome the frictional force, we can actually use the work kinetic energy theorem. Okay. So this is basically just substituting the values lah, sebab mv square half minus half mu square. We have all the values. We have v, we have u, we have the mass. So we can just directly plug it into this equation, and you should get the work done to be equal to negative 225 kilojoules. Alright, so this is your solution for question number 3 of quiz chapter 5.